Have you ever heard a climate change skeptic argue that climate change is natural and not being caused by humans? After all, the Earth has undergone colder and warmer periods throughout its history. But what causes these large-scale changes in climate? Actually, the answer doesn't lie on Earth, but rather out in space. It has to do with the Milankovitch cycles.
The Milankovitch cycles are 3 cycles involving the Earth's orbit that affect the long-term climate pattern. First off, the orbit of the Earth is not a circle, but an ellipse, with the Sun at one focus. The eccentricity, or ovalness, of this ellipse changes because of the gravitational pull of other planets. The Earth also doesn't move at a constant speed around the Sun. Instead, if you draw a triangle where the first point is the Sun, the second is where the Earth started, and the third is where the Earth ended, the area of that triangle is the same over the same amount of time, no matter how close or far away the Earth is from the Sun. This means that the Earth actually moves faster when it's closer to the Sun and slower when it's farther away. When the Earth's orbit is more circular, like it is now, its foci aren't as far apart, which means that the Earth can't get as far away from the Sun. This means that the Earth gets more solar energy even at aphelion, the point in its orbit farthest from the Sun. It also spends less time farther away from the Sun. When the Earth's orbit is more elliptical, the opposite happens. The Earth can get farther away from the Sun, therefore getting less solar energy, and it spends more time there. The tilt, or obliquity, of the Earth is another cycle. The Earth's tilt actually isn't always 23.5 degrees, but instead varies between about 22.1 and 24.5 degrees. How much the Earth is tilted changes how close or far each hemisphere can get from the Sun. When the tilt is larger, more energy goes to the poles and the seasons are more severe. The final cycle involves Earth's wobble on its axis, technically called precession. To picture this, imagine how a top wobbles as it slows down. This sort of wobble is what Earth is doing on its axis. Precession affects seasonal contrasts, making them more severe in one hemisphere and less severe in the other.
So now that we know what the Milankovitch cycles are, how do we know that they aren't causing climate change? Well, for one, according to the Milankovitch cycles, we should be going into a glacial period right now, not getting warmer. Secondly, paleoclimate data has shown a strong positive relationship between atmospheric CO2 levels and temperature. We currently have about 15 billion tons of carbon dioxide in our atmosphere, so that has to be doing something. Thank you for watching!